Now we are going to see the one more deletion operation in the different place, that is a deletion and node at the end. So what I have to do, in the previous one we have seen how to delete the first element just by replacing the start address with the start next one. After that this is going to point to this one. The task is completed, right? But here the case is different. What is the case now? I need to delete the last one. How can I get the last one? How can I get the last one? I need to start traversing from the beginning till I need to reach the last pointer. To this point I have to reach. How can I say that I am at the last position in a single linked list? The last linked list is going to have the address null, which indicates that this is the last element in a single linked list. Now I need to delete this one. For that purpose, first we need to start moving from the beginning and I need to reach up to here. After reaching to here, come back one step back and change this address as a null. After that, I can deallocate the memory. This is our task. Now, to perform the same task, we will see one by one, logic wise. In order to delete anything, first of all, I require the temp pointer. One extra pointer is indicated. So how we have to declare that one means struct node pointer temp, and initially that temp value also should start from the beginning, not from the anywhere. It should start from the beginning. How can I do that? If I write a struct node pointer temp equal to start, and if you observe this one, we have discussed that I need to delete this one. But before deleting this one, I should come one step back and I need to make the next address as a null. I need to make the next address as a null. After that, I can deallocate the memory. Yes or no? Which means that after reaching to the last point, I should come back. How can I come back? By taking the previous equal to null. So here I require the two pointers. One is a temp pointer to reach to the last one, and the previous pointer is required to specify the previous element. Initially, temp value will be same as a start and the previous value will be null. Temp value will be equal to 100 and the previous value will be equal to null. Now we will start traversing from the beginning. Here if you observe this one, we are taking a temp. I need this temp pointer to traverse. How can I traverse that one? While temp next not equals to null. See, I should traverse from the first element to the second element to the third element. This is called as a traversing. Now how can I move forward means by writing the code while temp next not equals to null. Observe, what is the temp value here? 100. Come to the 100. 100 next is 200, which is not equals to null. The condition satisfied. If the condition satisfied means I am going to send this previous value into the temp value into the previous one. Now see, initially previous value was a null. Now what I am doing, once the condition satisfied, once the next one is not null means I am going to change the temp value into the previous one. Initially temp value is 100. Now we are changing it as a previous equal to 100. After that, I will move forward. Temp equal to temp next. If you write this one, what happens here? Temp equal to temp next. What is the temp value here? 100. 100 next is 200. Now we are going to change the temp value as a 200. Yes. Now the temp value is changed as a 200. If you observe this one, now this one is pointing to the previous one. This is pointing to the previous one. This is pointing to the temp. Yes, this is what we require, right? Why? Because after reaching to the last one, what happens? I should change the address of the previous one. This is what we are happening here. The previous one is pointing to the first one and the temp is pointing to the next element after the previous. Done. Now again, the condition will repeat. This is a while loop. Until the condition fails, we are going to be in this same one. So again what happens? While temp next not equals to null. What is the temp value now? 200. 200 next is 300, which is not equals to null. The condition satisfied. So again I'll get into the loop. Now again we are going to change the previous value with the temp value. Previous value with the temp value. Initially the previous value was 100. Now we are changing that previous value from 100 to 200. I am sending the temp value into the previous one. After this one, again, I need to change temp equal to temp next. Temp equal to temp next. See, now the previous one is pointing to this one and the temp is pointing to this one. The condition satisfied again. Again, I'll go back to the loop while temp next not equals to null. What is the temp value here? 300. 300 next value is 400, which is not equal to null. The condition is again satisfied. So again, what we have to do? Again, we need to change the previous value. That is previous value equal to temp. Now again, whatever the temp values are, I'm going to store it in the previous also. After this one, temp equal to temp next. So what I have to do? 300. 300 next value is 400. I'm going to change that temp value as the 400. Done. Now again the condition. Again we are going to have to check the condition. While temp next not equals to null. While temp next not equals to null. Observe there. Check the condition while temp next not equals to null. Come to the 400. 400 next is null. The condition is not satisfied at this condition. Where we are not satisfying the condition here, this one became the temp and this one became the previous. After reaching to this point, what I have to do? I just need to change the previous value. Previous next value as the null. After that, I can free the temp. See, previous next equal to null. Initially, the previous value is 300. I need to change this next address only. How can I write the code means? By writing previous next equal to null. Which means that here this value is changed as a null. After that, free of temp. Free of temp. When you use that keyword free of temp, what happens here? The memory which is there in the temp, it will come to this particular memory space and the memory will be deallocated for that particular element. In this way, we are going to delete a node at the end. So, in this one, what we have decided, here we require the two pointers. One is the temp pointer, the other one is a previous pointer. Temp pointer will help you to traverse from the beginning till end point just by writing the condition temp equal to temp next. Now, whenever I am moving forward, the previous element, the previous pointer should also go along with the temp. How can I do that? By just assigning the value previous equal to temp. Just by assigning previous equal to temp and temp equal to temp next. After reaching to the last point, just by writing previous next equal to null and free of the temp, we can deallocate the memory. Yes, this is what we have seen till now. Next one is, this is the algorithm. If the list is empty, what it should say? It should say that the list is empty. If the list is not empty, which means that I should traversing from the beginning to the till end point. For that, we require the temp pointer equal to start. Initially, we require the temp pointer and the temp should start from the beginning. And the begin address is there in the start. So, I am sending the start address into the temp. After that, previous equal to null. We require one more pointer. Why? Because I need to change the previous element address. That's why we require the previous pointer also. And initially it will be null. While temp next not equals to null, what I have to do? I should change the temp value as the previous one and the temp value should go forward. The previous value should indicate this one and the temp should indicate the next variable. That's why we are writing these two lines. Until the condition is satisfied, I will be moving to this particular place. This one will be indicating the previous one and this one will be indicating the temp at the end of this while loop. After reaching to the last point, I should just change it as a previous next as a null. After that, free of temp, deallocate the memory which is there in the temp. It will be at the 400. Done. This is a complete algorithm. Now we are going to see this complete algorithm in the Turbo C. Like how we have inserted, how we have performed the deletion at the beginning. Now we are going to add the same function, deletion at the end to the same program.
Yes. Now deletion at the begin is completed. Now we are going to see the deletion at the end. So these are the functions already we have returned previously. Now we are going to continue the same program by adding an extension function that deletion at the end. So before you start the main program, Let us get into this deletion function. Void delete at end function. Okay, till now we have seen this one, right? What I have to do here, if the list is not empty, if the head is not equals to null, I should traverse from the beginning till the end point, yes or no? For that purpose, I require the one extra pointer, that is struct node pointer, temp, comma, and I need one extra pointer, that is a previous pointer. We have already discussed that why we require the previous pointer. Why? Because after reaching to the last one, I should move one step back and I should make that next address as a null. For that purpose, we require the previous pointer. Done. Now, initially the temp pointer will be same as that of the head. Done. And the previous pointers will be equal to null. Initially, the previous pointer value is null. Done. Now, what I have to do? I need to start traversing, right? How can I traverse? While temp next not equals to null. Why? Because if the temp next is null means that is the last point, which indicates that that is the last point. So I need to rotate my loop till I get the last pointer. What I have to do? First, I need to send my temp value into the previous value. So previous equal to temp. After that, the temp value should move forward. Temp equal to temp next. Done. So with this loop, we are going to move till the last point and the previous pointer will be pointing to the previous one and the temp pointer is pointing to the last one. After reaching to there, I'll just make that previous next is not equals to null. I'll make the last one equals to null. After that, we are going to write just free of temp. Done. Okay, all these things will happen if the head is not equals to null. If head is not equals to null. If head equals to null means what should happen? It should display printf. The list is empty. The list is empty. Slash. And here the return statement will help you to come out of the function if the value is null, or else then only I'm moving forward. I will rotate this loop till I delete the elements successfully. So here I'm going to add deleted successfully. This deleted. At end. Slash. Yes, up to here our function is completed. So what we have written, if head equal to null means we are going to say that the list is empty, or else what I have to do with the help of this while loop, I am moving till the last element while temp next not equals to null. I'm just going to point the previous pointer and I'm just moving forward till the last element. After reaching to the last but one, I should make that next value as a null. Why? Because that will be the last element now. After that, free of temp. The temp is pointing to the last pointer. With this one, we are going to complete the function deletion at the end. The next one is I need to make the choice, right? Even I should include this deletion at the end in my choice. So here I'm going to add that statement printf 6 to delete at end. Yeah. So again, even in our main program, I need to add that case, that is case 6. Delete at end function. After that, add the break statement. Break statement. Done. Now save your program by pressing F2. Now compile. I got 2 errors. Yes, here the semicolon should be here. Again, save the program. Compile the program. Done. Now control F9. Enter your choice. Again, let us go with the insertion first. Enter your choice 1. Let me insert the value 56. Yes, and again I would like to go with the insert at the position. I will go with the fourth option. Now enter the position 1. Enter the value 12. Now again go with the option display. We can see that 56 and 12 in the second position we have deleted. Sorry, 0 index, first index. In the first index it placed. Let me check once again. Insert at the position. I want to insert it at the second position. And let me give the value 43. Enter your choice 2. Yes, 0, 1, 2. In the second index we are placing our value. Done. Now I want to delete the element at the end, right? Let me choose the option 6. Node is deleted at the end. Yes, the node is deletion at the end is done. Let me go with the option display option. You can see that the last element is deleted, 56 and 12. Again, let me perform the same thing again. 6. Node is deleted at the end. Again, go with the option display. Observe there 56 and 12. I need to perform the deletion at the end, which means that 12 must be deleted. Yes, now go with the option display. We can see that only 56 is there, 12 got deleted. Right? Done. Now let me exit this.